Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy, and today I'm starting my series on lessons learned in amateur astronomy over the last couple of years. Now, many times when people talk about amateur astronomy, they talk about the telescopes. So we've got a research grade instrument up there called the RASA 11. We have an 8-inch Ritchie Chrétien, and then we have probably my favorite one, a little 80 millimeter refractor. Now that said, this video is not going to be about telescopes because that's the wrong priority when you're getting into amateur astronomy. Your first priority is to get a good mount. So let's cue up the music and get going. Now, a lot of people may be surprised to hear me say that the very first thing that you need to buy when you go into astronomy is a good mount. The reason for that is no matter how big your telescope is, if you can't point it accurately at an object that you want to see, you're not going to see it. And this becomes more important the larger the telescope. So many people come into amateur astronomy with something called aperture fever. They want to get the biggest telescope that they can afford, and they have no idea what they're going to put it on. What are they going to do? Strap it to the roof of their car? How are they going to track stars with that? In order to track objects in the sky, you need a good mount. And the type of mount that I will recommend is an equatorial mount. Let's go see what that is. Now I'm going to put links to all of my mounts in the description of this video, but we're going to start off with this one. This is a Skywatcher equatorial mount. Like all equatorial mounts, it has a certain set of features. Now your telescope will either have a Vixen or a Losmandy rail. The Vixen rails are rather narrow and the Losmandy rails are quite wide. They're for bigger telescopes. One pro tip is that if you're going to get a mount at this stage of the game, get yourself a mount that will accept both types of rails. So I've got a small telescope locked into this mount right now. With this knob back here, you change the overall angle of the mount. And with these two knobs right here, you change the azimuth of the mount. And that is used for something called polar alignment. Now, once you have this mount aligned so that the telescope is pointing directly at the north celestial pole or the south celestial pole, as the case may be, now you're ready to start observing. To understand how the mount works, it's best to kind of turn it on its side like so. So, when you turn the mount in this direction, you are adjusting it in declination, which is the same thing as elevation. Now, as you rotate the mount this way, you are changing it in what's called right ascension. So when you lock on a star or an object at, say, this position right here, in order to track it, this motor will cause the mount to slowly rotate and it'll follow the star throughout the evening. Now, how do you select a mount? Well, first of all, you're going to want to get a telescope mount that has a weight capacity at least 50% more than your astronomical gear. As I said, this little refractor is probably one of my favorite telescopes. By the time you put a camera on it and a guide scope and the other usual stuff that goes with it, it weighs 9 or 10 pounds. The reason that this didn't work for the original owner of this telescope was that he put it on a mount that was rated for 7 pounds. It was way too heavy for the mount. This telescope at 9 pounds will barely fit on this mount, which has a capacity of about 11 pounds. This is really good for putting your camera on to get nice pictures of wide field objects like the Milky Way. It's not the greatest one for putting a telescope on, and if you do put a telescope on it, this is probably pushing the limit of what you can put on it. Compare that to these other telescopes. You need much bigger mounts for that. Now, if you want to do astrophotography with a camera, this is a perfect mount for you to use. You can put a 300 millimeter lens on this and you can get decent pictures of Saturn, the moon, the moons of Jupiter, and even some of the larger celestial objects, like some of the big nebula, the Milky Way, perhaps even the Andromeda Galaxy. However, if you want to put a bigger telescope, say something on the order of this Ritchie Chrétien, which weighs about 19 pounds, you want to get a bigger mount, something that has a capacity of 28 to 30 pounds. Now, there's a couple of things that you want to do if you're going to go to that size. First of all, you want what's called go-to capability. You want a computerized mount that you can say, I want to look at Saturn. You say, go to Saturn, and it goes right over to Saturn. Second of all, you want to keep the number of wires coming off of it at a minimum. Now, when I first got into astronomy, I answered an ad on Facebook Marketplace, and I went out and I bought a little refractor telescope, about a 5-inch refractor. And it had a stand and an equatorial mount that came with it. And it was one of those things that you used to see when you were kids, and they had little knobs that you would turn to track the object, and you had to manually sight it. Now, the next mount that I got that was an actual astronomy mount was something called an Explore Scientific Exos 2 PMC-8 mount. And it had a capacity of 28 pounds. It was a computerized go-to mount, which meant that I could hook it up to my computer, and I could say, I want to look at Saturn, and it would go and kind of get over in the general direction of Saturn. Now, there were a couple of disadvantages to that mount, and I'm going to share them with you because I wouldn't buy another mount like that. First of all, the computerized section of the mount should be contained within the mount itself. On the Exos 2, the PMC-8 part of it is this box. Now, you have to hook this box up to the mount manually with cables, one for the declination motor and one for the right ascension motor. And as you can see, they're serial ports. Now, this is the 21st century. We use USB ports in this century. Serial ports were back in the He-Man Master of the Universe age. So since these come with serial ports, what you have to do is you have to get a special adapter to go over to a USB port. That's $30. Plus, what are you going to do with this enormous box? Now, there's a way to mount it on a leg, but then you still have all of these cables running around to get tangled up. And you may remember when I first started doing this, one of the problems that I would have occasionally is I would have what's called cable binding, which meant that the cable stretched and caught on something and stopped the mount from moving, and all of a sudden I lost all my tracking. Don't do that. Get a mount that contains the computer, this box, within the mount itself. So you just have to plug in something that's a glorified printer cable, preferably on a part of the mount that does not move. Now let me go ahead and show you my recommendation for a mount in the 28 to 30 pound class. This is something that's affordable. It'll take a variety of telescopes, up to even decent sized ones. It'll take a 9¼ inch Schmidt Cassegrain with no problem at all. Obviously it won't take that monster in the back, but by the time you're buying something like that, you should already know all this stuff and you know exactly what you're looking for in a mount. This series is designed to help you not make the mistakes that I made when I was young and stupid, just getting into the hobby. Now, a word on the cost of things. If you want to get into the astronomy hobby, you're going to be paying some money. Probably to get a decent scope and a mount, you're going to spend at least $1,500. My recommendation to you is forget buying the telescope and spend that whole $1,500 on the mount. Trust me, the telescopes will follow. And if you have a better mount, you can do more things with it. And once you can do more things with it, you start getting specialized telescopes to do those things. For example, my small refractor right here is ideal for looking at very large nebula in the sky. You don't have to worry so much about tracking. And the other thing that it'll do is that it'll see satellites. Now, one of the things that you want to do is you want to make sure that your mount is fast enough to actually be able to track the satellite. So when you call up Woodland Hills Camera and Telescope, which is out in California, their website is telescopeswithans.net. And you ask for either Victor or Dan, they're going to get you set up. Tell them what you would really like to do with your telescope, and they'll help you select the perfect one. Now, that's not a paid endorsement. Shamrock Bank's Observatory is primarily equipped with instruments that I bought from these guys. Their service is excellent, and I would highly recommend them. However, there are a number of other good ones out there too. Orion is a good telescope company. Starzona is an excellent telescope company. There are a variety of them. I happen to buy my stuff from Woodland Hills primarily, and I've always been very pleased with their service, and I think you will be too. Now, a quick word about compatibility of equipment. When you hook your telescope up to your computer, you have to download a software package that allows the telescope software to talk to your computer hardware. That's called ASCOM. And once you've downloaded the ASCOM driver, you have to download specific drivers for each mount. Now, one of the problems that you can run into is that you can have a ZWO camera on a Skywatcher mount with some off-brand focuser, and then a dew heater that's made by somebody else. You have all of these different manufacturers on one astronomy rig. Now, on the main pier of my observatory, I've got a Celestron CGX-L mount that has a capacity of 75 pounds, and I need it because I got that water heater back there. Now, that's a Celestron mount. It comes with some software that runs that mount. I also have a Celestron dew heater, which is completely compatible and just plug and play with a Celestron software. I also have a Celestron autofocuser on it, and that too is plug and play. It's less heartache, it's less problems with incompatibility. If you're going to go ahead and get this stuff, try and pick a company like Celestron that makes all of the accessories that you're eventually going to need. For example, you could use focusers. That's a little motor on the back that adjusts the focus very finely and very precisely without you having to actually touch it and jiggle the telescope. You have dew heaters. Now, those aren't quite as much, but some of them have sensors and such that read the ambient temperature and humidity. You might want to decrease the amount of software running on your computer so that everything works together. Now, with a black and white camera, you can play tricks with it and make color images with it by using what's known as filters. So you can have a red, green, and a blue filter on a little wheel that automatically turns. You take an hour's worth of image with each and then combine them in something like Adobe Photoshop, and you end up, voila, with a color picture with very fine grain from a monochrome camera. Now, when you go a little bit more advanced, you'll find that in addition to red, green, and blue filters, you can have what's called narrowband filters, which help cut down on the amount of light pollution. And those are things like hydrogen, sulfur, and oxygen filters. They look for the color of light that is emitted by those atoms and nebulae. And then you can assign a color to each one of those particular frames and develop a color photograph, just like you did with the standard red, blue, green filters. To demonstrate how quickly this can get confusing, look at this telescope right here, my favorite one for looking at asteroids. This is a 8-inch Ritchie-Chrétien telescope made by Orion. So here's the telescope from this point forward. This is a Primaloose autofocuser, or robotic focuser. Great instrument. This is what's called an off-axis focuser, and there's a ZWO camera on it. This is also a ZWO camera, and on the front, I generally put little strips of heat tape, so to say. Those are called dew heaters or dew straps. So you see how quickly these cables start adding up from just essential things. You got a guide camera, you have an imaging camera, you have a focuser. That's 3 separate cables already. You really want to add 3 more to the mix. Well, that's the first in the series, and I hope you enjoyed it, and I hope you found it helpful. A lot of people don't think that an observatory and astronomy is built around the mount. It's not built around the telescope. In our next episode, we're going to talk about why I have 5 different telescopes and why you should too. So until then, this is Bob the Science Guy signing out from Northern Michigan. Thank you very much for stopping by, and I'll see you again soon. Clear skies, everyone.
Mama, please make them hear me, or I can't teach them anymore. This rabbit hole's too deep for me. Feel my brain getting sun.